All right, my 8th grade friends, here we go. Factoring trinomials. Trinomials. Tri means three terms, three numbers. A squared plus 6a plus 8. 1, 2, 3. X squared plus 6x minus 72. 1, 2, 3. C squared plus 15c plus 44. 1, 2, 3. All right? So, here we go. Now, first of all, when we factor, everything is going to be in this, what you're doing today. This first one is something squared. This one, same variable, but no exponent. This third one, just a number term. A squared plus 6a plus 8. Well, first of all, when we factor it, we're basically doing the opposite of the FOIL method, okay? Where we're going to figure out what multiplication problem got us this answer, all right? And the fact that it's a squared tells me that it's a and a, all right? The fact that, and now I want to look at the 6a and the 8. What now I'm looking for at this point is two numbers that added together equal a positive 8. I'm sorry, I said that wrong. 8th grade, my apologies. What you are looking for now is two numbers multiplied together that equal a positive 8. The two numbers that you multiply together to get positive 8, you have to be able to add those two numbers together and end up with a positive 6. So we need to be able to add them to get a positive 6, and we need to be able to multiply them to get a positive 8. So, well, I'm thinking, okay, what are the multiplication problems that equal 8? Well, 8 times 1 and 4 times 2. Those are the two that come to mind. Well, 8 plus 1 equals 9. So I don't think I want an 8 and a 1. But 4 times 2 is also 8, and 4 plus 2 equals 6. So my final answer is A plus 4, A plus 2. And it really doesn't matter what order. You could have the 2 first and the 4 here. That doesn't matter. But you have to have A plus 4 times A plus 2. And if you were to go back and do the FOIL method, on the last example, I'm going to go back and do the FOIL method to walk you through. But I'm going to ask you to trust me at this point that if I were to go and do the FOIL method for A plus 4 times A plus 2, I would end up with A squared plus 6A plus 8. So let's go on to the second example. Once again, something squared plus something x minus 72. Now this is a little different now because it's a negative, okay? I'm looking for two numbers multiplied together that equal a negative 72. So I have to remember that if it's a negative answer as a multiplication problem, one of my numbers is going to be positive and one of my numbers is going to be negative. I'm going to have x and x because of the x squared. So that's understood. But the fact that the two numbers multiplied together have to be a negative 72, one of them is going to be a plus, and one of them is going to be a minus. Okay? So, here we go. I'm thinking, okay, I've got to get multiplication problems that equal 72, but then when those two numbers are added together, it equals a positive 6. So really what I want to start to do is think, well, what kind of things equal 72? Well, I could have 1 times 72. All right, I know that 72 is an even number, so it's divisible by 2. If I punch into my calculator 72 divided by 2, I find that that's 36. But adding 72 and 1 is not going to get me 6. Adding 36 and 2 is not going to get me positive 6. So let's think what else equals 72. 9 times 8 also equals 72. So that's not going to work. Now, if I think about my rules of divisibility, when I add 7 and 2, that gives me 9. And since 9 is divisible by 3, that tells me that 72 is also divisible by 3. So I do 72 divided by 3, punch that into my calculator. That equals 24. But any combination there does not give me a positive 6. Now remember, when I'm looking at these numbers, it can be a negative 1 times a positive 72. It could also be a positive 1 times a negative 72. But any combination, 2, 36, 9 and 8, 3 and 24, I know is not going to lead me to a positive 6. However, my rules of divisibility that I should know as an 8th grader, if 2 can go into a number and 3 can go into a number, it is also divisible by 6. It's a little trial and error, 8th grade. You're going to have to think about this, not be in a rush. You're going to have to get the right numbers. So when I go to my calculator and I punch in 72 divided by 6, I get 12. So I know that 6 times 12 is 72. Now that's interesting because I know that the difference between 12 and 6 is 6. So I'm thinking somehow I can make this work, which means I can either do negative 6 times 12, or I could do negative 12 times 6. Either one of these will equal negative 72. But it's very important. I guess can't plug something in and say, well, it equals negative 72 and the difference of 6 and 12 is 6. I have to have the right one. So I have to think, well, what leaves me with positive 6 when I add them together? Does negative 6 plus 12 equal positive 6? Does negative 12 plus 6 equal positive 6? Well, if I go to my calculator and I plug in negative 12 plus 6, that actually equals negative 6. But I don't want negative 6. I need positive 6. When I go to my calculator and I plug in negative 6 plus 12, I get positive 6. So my answer has to be a negative 6 and a positive 12. Very important that you do that right. Now, here I've got this one, c squared plus 15c plus 44. All right, so I know I'm going to start with c and c. And I know that this number's positive and this number's positive, so everything's going to be positive. I have to, because two negative numbers added together will not give me a positive answer. The only, and I can't have a negative and a positive number because this is a positive. So it either needs to be two negatives multiplied together to equal 44, or two positives multiplied together to equal 44. If it's two negatives, when I add two negatives together, it's going to be a negative number. So it can't be two negatives because I have to end up with plus 15. So this has to be two positives. Two positives multiplied together equaling 44. Two positives being added together equaling 15. So I got to think about, well, what equals 44 when I multiply it together? So I make a list. I could do 44 times 1. I know that 11 times 4 is 44. I know that 44 is an even number, so I can divide it by 2. 22 times 2 equals 44. I'm thinking about my basic multiplication facts, and 44 just doesn't show up. You get 42, because 7 times 6 is 42. You get 48, because 6 times 8 is 48, but you don't get 44. So I'm looking at these and thinking, okay, do any of these numbers add together equal 15? Well, 44 plus 1 equals 45, so I can eliminate that. 11 plus 4. Well, 11 plus 4 is 15. So if 11 times 4 equals 44, and 11 plus 4 equals 15, I can do c plus 11 and c plus 4. All right, let's look at one more, just so we get some different things. Let's say that I have m squared minus 7m minus 120. All right, well, this one has two minuses. So once again, I know that it's going to be m. I know that's got to happen. All right. The fact that this is a negative number, and when the two numbers multiplied together have to equal negative 120, one of the numbers has to be positive, one of the numbers has to be negative. That's the only way I can get a negative answer by multiplying, is to have a positive multiplied by a negative. But I've got a big number here in 120. So I've got to think, what in the world numbers can equal 120? Well, I know I can do 120 times 1. That's not going to get me 7. It's divisible by 2, and 120 divided by 2 is 60. So 60 times 2 could also work. I see that it ends in 0. Anything that ends in 0 is divisible by 10, and 10 times 12 would be 120. If it ends in 0, it's also divisible by 5. So 5 times something. If I go to my calculator, I plug in 120 divided by 5. I'm going to see that that equals 24. So that's not really a difference of 7. I see that it equals 12. I know that 6 can go into 12. Okay? And so if 6 can go into 12, 6 can go into 120. Okay? So 120 divided by 6 is 20. So 20 times 6 equals 120. Still kind of trying to figure that out. Okay. So I know that 4 can also go into 120 because 4 can go into 12. 120 divided by 4 is 30. So 30 times 4 is 120. Oh, that's not working. I know that 3 can go into it because 3 can go into 12. 3 can go into 12 4 times. So 3 can go into 120 40 times. So 40 times 3 also equals 120. But none of these are giving me a chance of any difference of 7. There's nothing here that's going to line up to make a difference of 7 when I do any addition or subtraction with these numbers. So I'm thinking, well, now what? Well, this is now where I have to use my rules of divisibility. First of all, I can see that if 2 can go into a number and 4 can go into a number, 8th grade, you should be able to know that if something is divisible by 2 and it's divisible by 4, it should be divisible by 8. So I'm going to go into my calculator. I'm going to plug in 120 divided by 8, and I'm going to find out that that's 15. Well, whoa, hold the phone. 8 and 15, there's a difference of 7. 8 plus 7 equals 15. So this is the combination that I'm looking for to get a negative 7. But now what's important is which one of these is going to be the negative and which one is going to be the positive. Well, I need a negative 7. So these are my two options. I can either have negative 8 times 15, or I can have negative 15 times 8. Both of those are going to equal a negative 120 because 8 times 15 equals 120. And if I have one negative and one positive, it's going to give me a negative answer. But which of these added together are going to give me a negative 7? Well, if I do negative 8 plus 15, I go and punch that into my calculator. Negative 8 plus 15, I find that that equals a positive 7. That's not what I'm looking for. I need negative 7. So I double check with negative 15 plus 8. Negative 15 plus 8, sure enough, equals negative 7. So my combination is negative 15, positive 8. So I'm going to do m plus 8 because I got a positive 8, m minus 15 because I got a negative 15, and that's the answer that I'm looking for. That is factoring trinomials. You're going to have to do some of this trial and error, 8th grade, okay? You're not just adding radicals or anything anymore. This is going to take a little bit of effort. Okay? I will be available to help you on this worksheet, factoring trinomials, during our normal 1 o'clock to 2 o'clock Zoom session on Monday, April 20. All right, we'll talk to you later. Bye.